Okay, so this is problem 346, moving average from data stream, easy difficulty. Given the string of integers and a window size, calculate the moving average of all integers in a same window. So you implement this moving average class. It has to initializing the object here with size of the window size. Double next returns the moving average of the last size values of the stream. So here moving average is 3, so you're going to have a size of window, sliding window 3. Next is 1. So I guess next, what that means is that's the next value you're going to insert into that sliding window. So here you have the window has just 1, so therefore the average is just 1. Now it has 1 and 10. The average of that is 5.5. 1, 10, and 13, that's going to be 14 divided by 3, that's 4.67. And then now the sliding window of 5, and then this 1 gets removed. So that's 10, 3, 5, 18 divided by 3, which is 6. So to implement this, so let's say, so basically whenever the size, the window does not yet equal the size, then we just add everything that we have so far into the window. So so we're first of all, we're going to have this self.size, and then here we're going to have okay, so self.size equals size, and then we'll have like self.window equals like an empty list. And so if self.window, so I guess we can append it to the window. And then if length of self.window is less than self.size, then we can keep the window as is. Else, or I guess less than or equal to. So then if it, so one, so if we have just 1, then it's okay. 1 and 10, that's okay. 1, 10, and 3 is okay. But now we had the 5, so now we have 4 elements that exceeds the size of the window. So now we have to remove the first element. So else, remove first element from self.window. So that's basically how this algorithm is going to work. And then one thing to keep in mind is that when we hit this 5, for example, instead of adding the 10 and 3 again with the 5, so this example uses only a window size 3, but what if this is like a really large number, like 3,000 or something, or okay, like 1,000, then there's no point in recomputing the sum of everything before the 5. That's going to be, 999 or 998 additions, and we already did that in the previous step. So really the only thing we need to do is just add this 5 here and remove this 1 to the sum, and then so we could take the sum that we already have and then just remove the 1 and add the 5 to it. So we have like another variable called like self.sum equals 0. And then so I guess we don't, so I guess self.window doesn't even need to be a list. We could just give it a number 0. And then here self.window plus equals to 1. And then if self.window so let's say we're equal to size, then keep window as is, otherwise remove first element from window. So we're going to remove it and then self.window minus equals to 1. And a self.sum plus equals to val. So here keep the window as is, and here now we would do self.sum minus equals to like the first element. So that would be the 3. I mean, that would be the 1 here. Then it would be the 10. So if you have 10, 3, 5, you add another number, then you remove that 10. So we need some way to keep track of like what the first number is going to be. So in this case, it's 1. Then we're going to have the window including 1, 10, and 3. Then we have the 5. Then the 1 gets evicted, and now 10 becomes the first number. So, and then we have to store the 3. So basically, I was wrong. We do need like some kind of data structure that's going to store each element. So I guess sum would, or window would be, we can call it like a deck. So then sum the value, append val, if length of self dot window less than or equal to size, keep it as is, else. So then remove the first element. We can call this popped equals self dot window dot pop left because we want to remove the first element in the window, and then sum minus equal to popped. Okay, so it looks like this, there's nothing going to be in here, so we can just change, we can move this else to up here. And then, so now we got the sum, and then we would just return self.sum divided by self.size. And that should be it. Let's just run through these examples just to make sure. So you got size 3 here. Self.window is going to append 1. So this is going to be 1. Self.window is not greater than self.size. So then we return, okay, so this is wrong. Self.size should not, so it's not going to be self.size. It's going to be length of self.window. Because here, the window is only size 1. So it'll be 1 divided by 1 is 1. Then now we add the 10. 1 plus 10 is 11. This does not get hit. So then we get 11 divided by 2, which is the 5.5. Then now we add the 3. 11 and 3 is 14. This is not hit, so then it'd be 14 divided by 3. That's 4.67. Then now we add the 5. So now this becomes 19. Now the window is size 4, which is greater than 3. So now we gotta remove the first element, which is the 1. Then this would become 19 minus 1, which is 18. And then 18 divided by 3, which is 6. So it looks like this should work. And it passes all test cases. So that's it. Thanks for watching.